let's see the continuous variables and continuous variables. Now let's see the continuous variables. So basically, forget the spelling. So basically, we are going to find the distribution of the continuous variable. We will consider continuous all those that are non-temporal and non-discrete. That means all the variables that are not temporal and that are not discrete, we will consider that as the continuous variable. Let's make let's find out. Continuous vars is equal to var for var in num vars. Why we are calculating num vars? Because we are only dealing with the numerical values for now. If var not in discrete vars plus year vars plus id, okay, plus id. If all the variables that are not there in these three categories, we are going to calculate the length of continuous variables. Let's see. Okay, there's an error here. Where in this is in, okay, 20. So there are 20 continuous variables. There are basically 20 continuous variables in our data set. Okay, let's see the visualization of all these data set of all these continuous variable. So we are going to call for the continuous vars dot head. ID lot front age lot area. Okay, so these are the continuous variables we have. These are the variables that are having the continuous variable. So basically these, okay, so now we understand what are the continuous variable. For now, all the variables that are not discrete, that are not temporal, are called the continuous variable basically. And now let's see the distribution of these variables and also check the relationship between the sale price. We are not going to check the relationship for now. We are going to see the distribution of these variables. So we are going to create a function of analyze distribution, and again it is going to accept two things, and then df is equal to df.copy. Simply create a shallow copy of it. Now df where, let's create a histogram this time, histogram, and we'll be having the bins of 20. If we'll need more, we'll increase the value here. Okay, and then plt.x label, okay, and number of houses out there, plt dot, basically number of houses will be on the y label because we are having the number of houses in the y axis. And then plt dot x label, we are going to have variables for it, that, and plt dot title, we can say where, why not where, okay, and then plt dot show. Okay, now for where in continuous vars, analyze the distribution and pass the data and the value. Let's see if there's an error. There is an error out there. plt.x label is having an error here, and why is that? Okay, I have to run 2 times, that is why. Silly mistake. Now all the all the relationship is now given now, and let's see what it look like. Okay, okay. So as you can see that they are not that much formally distributed. They are not formally distributed, including the target variable sale price. We haven't excluded the sale price for now, and these are not formally distributed. Okay, as I was expecting, but for the linear models to perform best, we need to account for non-Gaussian distribution. Okay, since it is not a Gaussian distribution, it is a non-Gaussian distribution. That means it is not a normal distribution. I hope you know what is normal distribution. So basically, we need to take account for this. We have to take care of this, of all the non-Gaussian distribution. We will transform our variable in the next video, definitely in the feature engineering video, but for now we are just analyzing it. Again, I know you are getting irritated for it, but analyzing is analyzing, feature engineering is feature engineering. Don't take two boards at the same time, take only one board. So analyze the whole data set first and then feature engineering. That is the rule here. Okay, so now let's calculate the log transformation of it. Let's calculate the log transformation of it, and we are going to create the def analyze we are going to transform the continuous. Okay, what's the spelling? OUS conti, what was that? Yeah, and df comma var. Okay, df comma var, and create the shallow copy of it. Okay, and log does not take negative values, right? Yeah, it does not take negative values, so let's be careful and skip those variables if there are negative values. So if 0 in data var dot unique, I'll pass. Okay, simply I'll pass. Else what we can do is we can have df var is equal to np dot log and df and var. Okay, so we are calculating the log of it. Again, let's transform the df var dot, let's plot on the histogram with the bins 20. Let's see what will happen, and let's have the labels out there. Y label, number of houses out there. plt dot x label will be var, as we did before. plt dot title will be var, and plt dot show will be nothing. Now let's iterate over the cont vars, and we will be analyze transform continuous. Okay, we are going to call the function here, and then we are going to pass, just a second, data and the var. Okay, let's run it. I'm expecting that this will become continuous. Okay, just a second. Yeah, indentation. Okay, yeah, it ran in the first go. Wow. Now as you can see that it is much better spread of values, much better than before. It is not uneven, at least it is not uneven. Okay, and for most variable we have used the logarithmic transformation. Most of the variables, since we cannot deal with the negative values, so that is why we have rejected, we have passed for that. and this engineering step will most likely to add performance value to our model. Okay, so this, whenever you have a non-continuous, that means not continuous, that the not non numerical, not numerical, what I'm saying, non normal distribution. It is, if since if your variables are not having the normal distribution, perform the logarithmic transformation. It will help a lot in the in the model performance. Okay, so this is how we are going to build our we are going to analyze it. Now it is having much better distribution, it is having the normal distribution now. Okay, that is better now. So let's explore the relationship between the house price and the transformed variable with a much more detail. Okay, let's explore the relationship. We haven't explored the relationship between these. So transformed, analyze, continuous. Okay, so basically continuous. Ignore the spelling for now. And we are having def and where. Now create a shallow copy of it again, df.copy. So let's check it. So now what we can do is, again, if since we cannot deal with the zero, we cannot negative numbers, so we have to do with data where dot unique, and I'll pass for it, else df where is equal to np dot log, and df where here basically, and then df of the sale price is equal to np dot log df sale price. I hope you are understanding what I'm writing here. So basically we are transforming the variables from simple var to log transformation. We are again, and we are transforming the sale price in the log transformation again. Okay, now let's scatter plot. Let's use the scatter plot, and we will be having the df var comma df sale price and plt dot y label, we can say sale price, plt dot x label, we can say the var here, and plt dot show. Now for var in count vars, so what we can do is we can calculate the, if var is not equal to the sale price we have, we can say that transform analyze continuous, and we can have the data and the vars. Okay, invalid syntax. Okay, this is the dot. Yeah, now the scatter plot has been put up. So now you can there's a much better thing. From the previous plot we can observe some monotonic association between sale price and the variable to which we have applied the log transformation. For example, see the gir live area. Where is that gir live area? See this one. There is a proper linear transformation. The relief area is really affecting the sale price here. So there's a proper linear transformation. Okay, this is also having some proper linear transformation. Okay, this is also showing some of the linear transformation, but not that much. This is properly scattered, and this is also showing some of the information. So we have a much better plot after uh, putting the what log transformation in our variables. So now let's analyze the outliers.